we're going to talk about some very important properties of logarithms. Here are the first four properties. Let's assume that the letter A is a real number that's greater than 0 and not equal to 1. For my first property, if you ever see log base A of A, you're going to write that this is equal to 1. We can actually prove this because a to the first power is equal to a. And remember, a logarithm is an exponent. So whenever you see this, you're taking this base, you're asking yourself, this base to what power gives me what's inside this log? And of course, a to the power 1 is equal to a. So that's the first property. And then the second property is log base a of 1 is equal to. Now, you could probably solve this just thinking about it. This is going to be 0 because a to the power 0 is equal to 1. So let me give you a couple of examples. So if I have log base 3 of 3 plus log base 5 of 1, we can actually solve this because log base 3 of 3 is equal to 1 here, and log base 5 of 1 is equal to 0. So this sum of these two logs is just equal to the number 1. Here's the next property. If you ever see a number raised to a log and the base in that log is the same number, and then you have some number m here, or this m is greater than 0, this is just equal to m. For example, if I have 12 log 12 of 7, this is just 7. So what you can think of is like canceling this piece out, and you're just left with what's right here. This rule is very similar to the last rule because you're going to see a pattern. Notice with the last rule, we had a log a. This time it's a little reverse. We have log a. So if you see this pattern, this is just going to be equal to r, and r can be any real number here. So for example, if you have log base 10 of 10 cubed, this is just going to be 3. And again, you can think of it as whenever I see this, I can just cross it out. And I get what's left over here. So let's get some practice with these 4 rules. So we're going to work on these green problems here. Let's see if we can solve them. And then we'll worry about the problems that are in the blue a little bit later. So the first problem is number 13, and why they're numbered like this is because they're actually problems from a book. So it says log base 3 of 3 to the 71. Now look back at those rules, make sure you have copied them down, and see which one this looks like the most. Notice that I have the same base here as this number here. So what you do is you just cross it out and you're left with this 71. So this is just equal to 71. This one's similar to the last one. This one's equal to negative 13. This one might confuse you at first, but remember that ln is the natural log. It's the same thing as log base e. So this is log base e of e to the negative 4th. So what does this equal? It's negative 4. How about this one? We have log base e of square root of 2. So this is log base e to the square root 2. So these cancel out and I'm just left with square root 2. Which one does this look like? Here I have that pattern, 2 log 2. So this is just equal to 7. Cross this stuff out and just take what's left over here. This one is e log base e of 8. So this is going to be just 8. And the rest of the problems have addition involved. I don't think we can do this one or this one. So we're going to stop there with these problems, and we're going to do those in just a minute when I show you the next few rules. So the next four properties. For each one of these properties, if you see the letter A, we are assuming that A is greater than 0 and not equal to 1. We're also assuming that M and N are real numbers that are greater than 0, and if you see the letter R, it's just any real number. These are actually some of my favorite properties. I think they're interesting and they're fun to play with. If you have multiplication inside a logarithm like this, so you have log base A of M times N, that M and N is inside the log. This is equal to log base A of M plus log base A of N. So multiplication on the inside of a logarithm becomes addition on the outside. So we're just taking log base A of M and we're adding to it log base A of N. Again, let me repeat that. Multiplication here on the inside of a log becomes addition on the outside of the logs. And notice that the base here is the same. We're keeping this A here. You could also go in the opposite direction. If you have a log base A of some number plus log base A of some other number, then you can take this plus and make it into multiplication on the inside. Here's a quick example. So let's say we have log base 3 of, let's say 21. Well, this is the same thing as log base 3 of 7 times 3, which is equal to log base 3 of 7 plus log base 3 of 3. You see how I took that multiplication and made it addition? I could even simplify this a little bit further because this log here, this is just equal to 1. So this would become log base 3 of 7 plus 1. And this log I can't really simplify, so I'm going to leave it like that. Here's our next rule. This time we have division inside a logarithm. So think about it. If multiplication became addition, what do you think division is going to become? Well, division is subtraction. So if you have division on the inside of a logarithm, it becomes subtraction on the outside of the logarithm. So let's look at an example. Let's say we have log base A of, let's say, 12 over 5. Well, this is going to be, in fact, let me change this A to a different number. Let's say it's 3. This is log base 3 of 12 minus log base 3 of 5. In fact, you could put this in your calculator. If you're able to put this 3 in the base and take 12 divided by 5, take the log of that, and you'll see that it'll be the same thing as this. I want to show you that this log does work, these log rules work. So let me share my screen with desmos.com, and let's put in something like log of 25. Now remember, if I just see log here, we're assuming it has a base of 10. So this is log base 10 of 25, and I get 1.3795. Well, remember that 25 is 5 times 5. So if I put log of 5 and I add to it log of 5, I have 1.3794, exactly what I see here. Let's try the division rule. So let's do ln this time. So ln is log base e. If I take something like 6 over 13, I get this very strange number here, negative 0.7731. But now I'm going to put ln of 6, subtract ln of 13. And you can see I got the same answer. Okay. The next rule we're going to have is log base a of m to the r. Now, before we saw something like this. We had log base a of a to some power. But this time, this number doesn't have to be a. This is called the power rule. If you have a power inside a log like this, so a number raised to a power, you can actually just put it in the front. So this is equal to r times log base a of m. So for example, let's say we have log base 1/2 3 to the 4th. Well, this is going to be equal to 4 log 1/2 of 3. So I took that 4 and moved it to the front. The last rule I want to talk about right now is if you have that two things are equal, well then you can put any log you want in front of it and you'll get that these are equal, as long as they have the same base. So log base a of m is equal to log base a of n. So for example, 3 is equal to 3. Obviously, log base 10 of 3 is log base 10 of 3, right? This is going to become more interesting when we involve variables. So if we have something like x is equal to x squared minus 4, then you would take log of this side is equal to log of that side, or something like that. Okay, let's get some practice involving these properties. So we did have some problems that I marked, I think, in blue earlier that I want to look at. I want to look at them after a few sets of other problems. So I have them written down later on. So in these problems, I want to write each expression as a sum and or difference of logarithms. Express powers as factors. So what I'm doing is I'm just trying to expand these. I'm trying to write them as sums or have subtraction signs and no powers. You'll see this on your homework. No matter what class, if you're in my class or in some other class, you'll see this stuff in your homework. So the first one, and I'm going to actually write it down here. Problem 38, we have log base 3 of x over 9. So let's see if we can expand this using those rules, the last 4 rules I showed you. Okay, so I have division inside a logarithm. So that is the same thing as saying log base 3 of x minus log base 3 of 9. I can actually reduce this problem a little bit further because 9 is the same thing as 3 times 3, or 3 squared. So this is log base 3 of x minus log base 3 of 3 squared. And you can use that property where if you see this pattern here, you can cross it out and then pull the 2 in the front. Or just cross these out and you're left with this 2 here. So this is equal to log base 3 of x minus 2. Okay, so we did problem 38. Let's try problem 40. Is log base 7 of x to the 5th. There's not a whole lot we can do with this problem. I'm going to show you actually 2 ways to think about this problem. The easy way is just to pull the 5 in the front. This is 5 log 7x. But another way to think about this problem is this is the same as x times x times x times x times x. That's 1, 2, 3, 4, 5 x's. And this breaks into log base 7 of x plus log base 7 of x, because I'm going to have, remember, multiplication becomes addition on the outside. So 1, 2, 3, 4. 1, 2, 3. And then here's the 4th plus sign. So then I have 1, 2, 3, 4, 5 of these logs. So it's the same thing as 5 log 7 of x. Okay, let's try 42. So 42 says ln of e over x, and that e over x is inside this logarithm. Well, this is ln of e minus ln of x. Can we simplify it further? Notice that ln of e, that's log base e of e minus ln of x. And this is just 1. So this is 1 minus ln of x. Let's try 44. So we have ln of x e to the x. How can we break this? Well, notice that I have x times e to the x. So this becomes ln of x plus ln of e to the x. And now I have a power, and I can pull that power in the front. Or I can use that property that I have log base e of e. That would go away, and I'm just be left with x. So what I'm saying is you can do this, and notice that ln of e just becomes 1. Or you can use one of the properties we saw earlier where we just cross this out and leave this x, because we're going to get the same thing. So this is ln of x plus x. Now I do want to bring your attention to a mistake I see some students make. It is right here. They'll take this x and put it in the front right here. So what they'll do, let me write it, I guess, maybe I'll do it in a different color. So right here, ln x e to the x. They'll say that this is equal to x ln x times e. And then they'll get that this is x ln x plus x ln e. And then they'll get x ln x plus x, which is not what I have here. I don't have an x here. What was the mistake? Well, because they pulled the x in the front, they were assuming that everything here was being raised to the x, but the only thing being raised to the x is this e. And that property, when you pull a power in the front, everything inside that log has to be raised to that number in order to do that. Because this x is not being raised to this e to the x, I can't pull out in the front until I split this log like I did here. Okay, so we did 42 and 44. Now let's try 46. (46) says log base 2 of a over b squared. And they're also giving us some domain restrictions. And the reason for that, I mean, you can't put a negative inside a logarithm. I wouldn't worry at all about this. They're just trying to be careful about what you can use for a and b. It's not going to affect how we're going to do this problem. So log base 2 of a over b squared. This, notice that this is a divided by something on the bottom, so let's make that a subtraction. Log base 2 of a minus log base 2 of b squared. Now what can I do from here? I can pull this 2 in the front. So now this becomes log base 2 of a minus 2 log base 2 of b. And this is where that domain issue comes into effect. Although b squared is always positive, remember that if you take a 2 in the front, what has to be left here has to be positive in order to take the log of it, because the domain of a log is greater than 0. So this can't be a negative number, which is why they're putting that here. Okay, now let's erase that. And now we're going to try 50, no, over here, 48. I'm getting a little lost. Okay, let's try 48. We have ln of x square root 1 plus x squared. Maybe pause the video and see if you can break this up. Okay, so this is going to be, notice that I have an x times a square root. So let's break this. This is ln of x plus ln. I'm going to write this as 1 plus x squared raised to the 1/2. And notice that all of this is being raised to the 1/2, so I can put the whole thing up to the 1/2. And now I can pull that power in the front. So this is equal to ln of x plus 1/2 ln of 1 plus x squared. Now, a addition sign does not become an addition sign on the outside of a log, and it does not become a multiplication on the outside of a log. So that rule where we had, let me write it over here. So we had a rule that the log of m times n is equal to the log of m plus the log of n. This is a true statement. So you can go back and forth but the log of m plus n is not equal to the log of m times the log of n, and it's not equal to addition on the outside either. So it's also not equal to log of m plus log of n. So don't make this mistake. The only time you can break something into two logs and add them is if you have multiplication, and if you have division, you can make it subtraction. So if you have a minus sign here, you can't break it into a minus sign right here. So this is as far as we can go with this problem. Okay, let's try problem 50. So 50 says we have the log base 5 of the cubic root of x squared plus 1 over x squared minus 1. How can we break this up? Well, we have a division, so we're going to make this into a subtraction on the outside of these logs. So this is equal to log base 5 of x squared plus 1 to the 1/3 minus log base 5 of x squared minus 1. And from here, I can pull that 1/3 to the front. Now, if these were factorable, we could possibly reduce it a little bit further. This x squared plus 1 is not factorable over the real number, so we're going to leave it like that. This one is factorable. This is x minus 1 times x plus 1, so we can actually break this even further. So this is equal to 1/3 log base 5 of x squared plus 1 subtract log base 5 of x minus 1 times x plus 1. And now since we have multiplication, we can break that into addition on the outside. Now be very careful here because you have a minus sign. So this is minus, in parentheses, log base 5 of x minus 1 plus log base 5 of x plus 1. Just like that. And now you can distribute that negative. Okay, I see a lot of students will just make the first part negative and the second one they'll leave as positive. This negative has to go into everything here. It has to go there and to there because it's the negative of this product here. So if you want to distribute the negative, you're going to have to change the sign to a negative. Good question is, how far do I go? How do I know when to stop expanding these logs? Well, you want to factor as much as you can. So I knew that this was factorable, and that's why I broke it into pieces like this. Now this piece is not factorable. I know that because it's a prime polynomial. So a lot of this is just trial and error. Okay, let's try 52. So 52 says we have the log of x cubed square root of x plus 1 divided by x minus 2 squared. So there's a lot going on here. First off, the base of this log, because I don't see it, is assumed to be base 10. So just keep that in mind. I have multiplication on the front, and then I have in this denominator, I have a denominator, which means I have division. And in that denominator, I have something squared. It doesn't matter what order you do this, when you break it into addition or subtraction, because if you wanted to break up this numerator from this denominator, then you would use subtraction. You just need to make sure that whatever you do, the math makes sense. So like what I would do first is I notice that all of this is in the numerator and all of this is in the denominator. So I'm going to consider this as like log of A over B, where A is all of this and B is all of this. And so I can break this into log A minus log B. Not lob, but log. And then I substitute this A here and this B here. And then from there, I can break it down even further. So let's see, we have this is equal to log of x cubed square root of x plus 1 minus log of x minus 2 squared. Again, it doesn't matter the order that you do this, just as long as what you're doing makes sense. So I can break this first. I can make, because I see this is an x cubed times this. Or you know what, I could pull this 2 in the front. I think that's the first thing I would do. I would go ahead and put that 2 in the front, because that's something easy to take care of. And then I would break this log into log x cubed plus log. And now I have this square root. I can make it x plus 1 to the 1/2. Like that. And then what can I do? I can pull this 1/2 and this 3 into the front. So this is 3 log x plus 1/2 log x plus 1 minus 2 log x minus 2. And if possible, if I had something repeated, like if I had this was an x plus 1 and this was an x plus 1, and as long as the base is the same, I could add the coefficients. But since I don't have anything repeated in those logs, I'm just going to leave it just like this. This is as simplified and expanded as we can get it. Okay, so we've done 52. Let's do these last two. So 54 is the ln of x minus 4 squared over x squared minus 1 to the 2/3. So I have a lot going on in this problem. Maybe pause the video and try to solve it on your own and then come back and see if you get the same answer. So the first thing I would do is, because I have this 2/3 on the outside, I would pull it in the front. So this is equal to 2/3 ln of x minus 4 squared over x squared minus 1. And then notice that this 2, it goes with this numerator, but it does not go with the denominator. So I can't pull the 2 in the front. However, I can separate the numerator from the denominator. So this is equal to 2/3. Now be careful here. This 2/3 is on the outside of this entire log. So when you break it, it needs to be sent to everything in the sum. So this is ln of x minus 4 squared plus, actually not a plus, subtract, because of the division, subtract ln of x squared minus 1. Zoom out a little bit, maybe so we can see the whole problem. Okay, so this is what I have. Let's just double check. Now you have a few options here. You could go ahead and send in the 2/3. I think I'll wait. What I'm going to do is I'm going to try to break these logs down a little bit further. So I can pull this 2 down. And we saw earlier that this breaks into, I'm going to write it up here. This is the same thing as x minus 1 times x plus 1. So this will break into 2 logs. So we have, this is equal to 2/3, 2 ln of x minus 4, subtract ln of x minus 1 plus ln of x plus 1. I'm breaking this log up. And notice I have this negative right here, so that negative has to be sent to everything. So we can get rid of this parentheses, but we will have to change this sign. Okay, and then I also have this 2/3 in the front. Now, it's really up to your teacher, how far they want you to go, what they want to do. Like if it was me, I would say you could leave it like this. But another option is you could send in that 2/3 to everything. So this is the same thing as 4/3 ln of x minus 4, subtract 2/3 ln of x minus 1 minus 2/3 of ln x plus 1. So either one of these is the same answer. So either one would be fine for you to write. Okay, let's do one more in this section. The problem, oh, it looks complicated. This is 56. Didn't mean to do that. Okay, here we are. So 56 is the ln of 5x squared, the cubic root of 1 minus x over 4x plus 1 squared. Now definitely try to do this one on your own. Pause the video and see if you can break it down as far as possible. Okay, so we're going to get that this is equal to the ln. I'm going to break the numerator from the denominator, so this is 5x squared times the cubic root of 1 minus x, subtract ln of 4 times x plus 1 squared. Then from there, I put these little dots here so you know that that's what I'm going to do next. I'm going to break this into addition. So this is equal to ln of 5x squared. You can put parentheses around this if you want. Plus ln, I'm going to make this 1 minus x to the 1/3. Subtract ln of 4, subtract ln of x plus 1 squared. Now remember this was a plus, but because of this negative, it had to be distributed. This can break down a little bit more. We've got 5 times x squared, so this is equal to ln of 5, plus, this is ln of x squared, but you can pull that 2 in the front. You can pull this 1/3 in the front. And then you have this minus ln of 4, and then you can pull that 2 in the front. Okay, zoom out a little bit. Just want to double check everything. Okay. And I think this is as far as you can simplify it because all of these guys have different things inside the logs, so you can't combine coefficients or anything. Okay, so that takes care of all these problems. The next thing we're going to do is we're going to look at some problems where we actually have to do the opposite. So I'm going to give you things that have been expanded, and I want to condense them back into a single log. So let's see what we have here. Okay, the first couple will be easy. I'm going to do the ones in yellow, and then the other ones will be a little more difficult. So let's start with 58. We have 2 log 3u minus log 3v. So I want to put it as one single logarithm. So everything I've been doing, I'm going to like reverse it. So the first thing you can notice is you have a 2 in the front. You can put that back up here on as an exponent. So this is log base 3 of u squared minus log base 3 of v. And as long as these bases are the same, if you see subtraction on the outside, it becomes division on the inside. So now I've written it as a single log. This takes a lot of practice, you know. Sometimes it's not easy to see what you have to do. Okay, let's try number 60. So 60 says I have log base 2 of 1 over x plus log base 2 of 1 over x squared. Same base here. Addition becomes multiplication on the inside of the log. So this is 1 over x times 1 over x squared. And there's no real reason to leave it like this because 1 times 1 is 1 and x times x squared is x cubed. So let's write it as 1 over x cubed. Okay, problem 60 is done. Let's try Problem 62. So I have log, the base here is 10, x squared plus 3x plus 2 minus 2 log x plus 1. Okay, what I would do first is I do have a subtraction sign here, and you might think of just taking this and dividing it by, you might even put the 2 in the front of this, and that's not right, because that subtraction sign, that worked when you just had log and log. You didn't have numbers in front of those logs when you did when you broke something up from division to subtraction. So the first thing I would do is get rid of this 2 in the front by sending it back up here. So I'm going to put a 2 there, and then I can get rid of that. And because I did that, now I can combine these. This is the same thing as log of x squared plus 3x plus 2 over x plus 1 squared. And I'm curious, can I actually, first off, this is a 2. Can I actually simplify this a little bit more? What does the top factor into? The top is the same thing as x plus 1 times x plus 2. Is that correct? If you FOIL that out, you're going to get this here. And now you can see that I have an x plus 1 on the top and 2 of them on the bottom, so I can cross that out, and I'm left with just an x plus 1 on the bottom. So this is the log of x plus 2 over x plus 1. So that's what this simplifies into. Okay, let's try problem 64. Okay, so, I'm not going to rewrite it. I'm just going to look at it right now. You can see that I have log of something minus log of something. Well, minus will become division. So we're going to have this big fraction divided by this big fraction. So this will be log on the top, x squared plus 2x minus 3 over x squared minus 4 divided by x squared plus 7x plus 6 over x plus 2. Okay, can I simplify this? The answer is most likely yes, I can. What I'm going to do first is I don't like all of these division signs, right? This is the same thing as taking this one, this guy in the numerator, and multiplying by this guy flipped. So let's at least try to simplify it a little bit. This is the log of x squared plus 2x minus 3 divided by x squared minus 4 times x plus 2 over x squared plus 7x plus 6. Now, I don't want to multiply all of this out. I don't want to take this and multiply it with this, and then realize later that I could probably have simplified it some. So what I'm going to do from this stage is I'm going to see if I can factor some stuff. Like the bottom here, this is the difference of squares. It's the same thing as x minus 2 times x plus 2. And look, just by doing that, I can get rid of this top one and this bottom one. What about this guy right here? Is that factorable? So you have a -3. I think it is. I think it factors into x plus 3, x minus 1. Let's see. 3x, 2x, -3. Yeah, so let's cross this out and put that here. And what about this one? I think this factors into x plus 6, x plus 1. You have to be really good with your factoring here. So let's move that guy up here. Now, can we factor any further? Is there anything I can get rid of? So let's see. It doesn't look like I can factor anymore. So I'm actually going to write this as log. On the top, I have x plus 3, x minus 1, and then on the bottom, I have x minus 2, x plus 6, and x plus 1. Now you could FOIL this out and FOIL this out if you want to. I'm going to leave it just like that. All right, so we did 64. 66 doesn't look too bad. Let's give that a shot. Okay, pause the video and see if you can combine these. Okay, so I have 21 log 3x, 3 root x. Then I have plus log 3 9x squared, and then minus log 3 9. I could simplify some stuff already. Like this would simplify to 2 because this is 3 squared. But I do want to combine it as a single log. So I'm not going to try to simplify this kind of stuff. What I'm going to do is I'm going to start with this. Remember, I would like to make this addition multiplication on the inside and this minus sign division. But I have this 21 in the front. I need to get rid of it. So this is the same thing as log base 3. This is x to the 1/3 raised to the 21. Just putting that back up here. And then plus log 3 9x squared minus log 3 9. And then I'm going to work from left to right. I can combine these two. This becomes multiplication. So this is log base 3 of x to the 1/3. Actually, 1/3, this 27, we can multiply those. Sorry, 21, that becomes just 7. Because 1/3 of 21 is 7. And then this is multiplied by 9x squared. So again, what I did was I sent this 21 in. Remember, laws of exponents, 21 divided by 3 is 7. And then because I have a plus sign, here I'm multiplying. Minus log 3 9. And now I'm going to take all of this and divide by this 9. So this is log base 3 of x to the 7th times 9x squared over 9. And I can simplify a little bit in here because this 9 and this 9 cancel and the 7 and 2 add. So I get log base 3 of x to the 7, 8, 9, 9.